So hello friends, welcome back to my channel. So today I'm going to explain I'm going to solve 12th standard chemistry question paper 2022 Karnataka board. So part 2 video. So in my last video I completed till question number 35, that is part C question I have completed. Here part D we should start in this video. So part D, that is fourth main 36th question. First question they are given is they are asked to calculate the packing efficiency in simple cubic crystal lattice. They are asked for packing efficiency here. So let us draw a cube here. This is E. Let us take this as D. Okay. And this and this as let's take this to as B and C. Here A and here H. Okay. And here another two. That is F and G. So after this, so the edge length of the unit cell, let it be as the edge length be edge length of unit cell PA. Let us take as the edge length as A. Then A is equal to, then let us take it. Then let us take A is equal to 2R volume of particle, that is equal to pi or cube by 4 pi or cube by 3, and volume of unit cell A cube, volume of unit cell is equal to A cube, that is equal to 2R cube, that is equal to 8R cube. Okay. Packing efficiency is equal to volume occupied by the particle, volume occupied by the particle by, sorry, not this, from here, volume of the unit cell. This is the like formula. Next, so therefore it is equal to, the volume is 4 by 3 pi r cube, 4 by 3 pi r cube by 8 r cube is the volume of the unit cell. 4 by 3 pi r cube is the, here we got 4 by 3, so it is not 4 by r cube, 4 by 3 pi r cube. Okay, 4 by 3 pi r cube into 100 percentage we have to find, so therefore into 100, that is equal to 52.4% is the packing efficiency. Packing efficiency is equal to 52.4%. A1 is done. Now B, they have asked is we have to calculate the number of the particle atoms per unit cell in the body centered cubic PCC crystal lattice. So now calculating the number of particles in this PCC crystal lattice, let us write it. Here also same, a box means a cube. Yes. So from each corner, from this all each corner, from this each corner of the cube, each corner, continuous, so each corner, its contribution, each corner it gives contribution of per unit cell, contribution of per unit cell from this each corner of this cubic is 1 into 8 by 8. It will get answer, so that is equal to 1. So therefore the particle present at body center of the cube is equal to 1. Okay, so this is the answer. So now moving on to our so 1, then the number of particles per unit cell, the number of particles that we get per unit cell is number of particles per unit cell, per unit cell is equal to 1 plus 1, that is equal to 2. So therefore 2 is the number of per unit cell in the body cubic PCC crystal lattice. So if you know the answer, you can write straightly this one. Otherwise, you can explain also. It depends on you. Next, moving on to our next question, that is question number 37. A. They are given on the question as on dissolving 3.46 gram of non volatile solute in 100 gram of water, the boiling point of solution was raised to the that of pure water of 0.12 Kelvin. We have to calculate the molar mass of the non-volatile solute. So this is the question they are given. Let us write the formula first for finding the non-volatile solute. Mb is equal to Kv into Wp into 1000 by delta Tb into Wb. This is the formula. And Kb they have given already. Kb is equal to, let us write what all the things they have given. Kb is equal to 0.51 and Wb, that is the dissolving of non-volatile solute, that is Wb is equal to 3.46 gram and here kg, all you should mention kg, kilo per mole per second. Then delta Tb is equal to 0.12, that is temperature, Tb is temperature, and Wa is equal to 100 they are given, that is 100 gram of water it is soluting. Now we have to calculate Mb is equal to 0.51 into 3.46 into 1000 by 0.12 into 100. So therefore Mb is equal to 147.05 gram per mole is the answer we'll get after solving this. So this is the answer for question number 37. First question, question A. After this, so question A is done. So 3 marks you have got. Now, question B they have asked. Let us move on. Question B they have asked, what type of deviation from Rolle's law is observed when equal volume of ethanol and acetone are mixed? And we have to also mention the reason. Okay. So, what type of deviation? So, the deviation that we get when we observe when equal volume of ethanol and acetone are mixed is positive deviation. Positive deviation we get. The reason is due to this is the positive deviation is found due to weak interaction due to its weak interaction between acetone and ethanol. There is weak interaction between acetone and ethanol, or you can also say it as AB interaction. Let us take AB, it as AB interaction, or weaker than AB interaction, they are weaker than AA and BB interaction. Okay, so anything you can write. Now let us move on to our next question. So question B is also done. Moving on to our next question, that is means question number 37 is also done finally. So moving on to our next question, that is question number 38. Here they have asked, we have to calculate the value of delta G naught at 298 Kelvin for the cell reaction they have given. T8A. Okay. So for calculating the value of delta G for the reaction that they have given is first formula of the Gibbs energy. Let us write formula of Gibbs energy, that is delta G naught is equal to minus NF in. So here N is the number of electron transferred, N is the number of electrons transferred. So the number of electron transferred here is equal to, that is 2. 2 is the number of electron transferred here. And F is Faraday's, F is equal to Faraday's constant. So this constant you should remember, Faraday's constant, that is equal to 96,500 per mole. Okay, this they will be not given here. Yes, here also they have given Faraday's constant. See, so you can try. You have got that E naught cell, that is here E naught cell, that is equal to E naught cell is here. They have given 0. Plus 0.34 volt. After this, delta G naught is equal to minus 2 into 96,500 C per mole into 2.71 volt, and here also we should minus it 2.37 volt. So here also is minus. So when we do it, we'll get 2.71 volt is the E cell value. Delta G naught is equal to minus 55 lakh 23,030 C per mole, that is into also we have done. So this we got. Finally, delta G naught is equal to 52 point 52 3030 joule per mole. Let us take it as joule minus here delta G naught here 1 CV is equal to 1 joule. Let us take, so therefore it will be minus 52.303 kilojoule per mole is the answer we'll get. So this is answer for question number 38A question. So A question we have done. Now let us move on to our next question, that is question number B. So question number B, they have asked, we have to suggest two methods to prevent corrosion of metal. Okay, two methods to prevent the corrosion of metal. First, let us say first method is barrier protection method, or we can say it is painting. Coating also we say that method. And another one is the sacrificial method. Sacrificial method or sacrificial protection, that is the galvanizing method, and also it is greasing method also we can do, and many other methods are there. So they have asked only two, so I have written here three. It is better to, three is better than two, so therefore I have written three here. So question number B is also done, so therefore 38 question we have solved. Now moving on to our next question, that is question number 39. Okay, question number 39. Question number 39, here they have asked, we have to derive integrated rate equation for the rate constant of a zero order reaction. Okay, they have asked a question, integrated rate equation for the rate constant of a zero order reaction we have to find. So let us consider an order of reaction. Consider a order of reaction, that is okay, rate is equal to minus d into r by dt, that is equal to k into r dr is equal to minus k into dt. So integrate equation, let us integrate equation from both sides. Integrating equation from both sides. Let's integrate equation from both sides. After this integration of equation from both sides, we will get it as r is equal to, this one is first equation, r is equal to minus k plus I, sorry, k, sorry, kt plus I here, kt, equation 2, where I is the integration constant. Here I that we have taken, it is integration constant. Okay, then Let us take t is equal to 0. Let us take t as 0 and r is equal to r naught. Okay, where r naught is an initial concentration of this reactant. So from equation to here it begins r naught is equal to minus k into t is 0 plus 1. Equation 2 let us take. So therefore it becomes I is equal to r naught. So let us substitute equation 1 in equation 2 that we have got here. So therefore it will be r is equal to minus kt plus r naught, that is minus kt is equal to r minus r naught. So kt is equal to r naught minus r is the answer we will get. Okay, this is the integrated rate equation for the rate constant of zero order reaction. And also they asked you have to mention two factors that affect the rate of a chemical reaction. We also have to mention the two factors that affect the rate of chemical reaction. E is the question number. And also this also we can write it as K is equal to R naught minus R by P. So this is the final we'll get. Okay. So B1, let us write here only B1 that they have asked. They have asked mentioning two factors that affect the rate of a chemical reaction. They may be temperature, catalyst, and many other catalyst, and another one let us write that is concentration. Much concentration of that a chemical we are putting, and many other things are affecting on the temperature, means affecting on the rate of the chemical reaction. B. So 39th question is done. B also we have solved. Now moving on to our next question, that is question number 40. So we have moved on to our next question, that is question number 40. Here they are asked what is effective collision, and we have to write any two factors responsible for this effective collision. This effective collision, effective collision or the collision that results in the formation of product. Collision that results in the formation of products. So factors that are factors responsible for effective collision. Let us write factors that are responsible for effective collision. They are maybe proper orientation, and activation energy. These are the factors that are responsible for effective collision. So A question is done. Let us move on to our next question, that is question number 40. It's B question. Let us move. So they are asked here to show the half-life period of the first order reaction in independent of initial concentration of the reacting species. Okay. So B, integrated reaction rate equation of the first order reaction, that is K is equal to 2.303 by T into log or not by or. So at half-life, T is equal to T1 by 2 and R is equal to 1 by 2 or not. So therefore K is equal to 2.303 T into log or not by T. T1 by 2 is equal to 2.303 by K into log 2 it is. So therefore T1 by 2 is equal to 2.303 by K into 0.3010. T1 by 2 is equal to 0.693 by K. So question number B is also done. So question number 40 is done. Moving on to our next question, that is question number 41. So question number 41, they are asked to so here they are asked to give any three. So they are asked to give any three difference between lyophilic colloid and lyophobic colloid. Okay. So let us write the difference now. 41A. Lyophilic colloid, lyophobic colloid. So lyophobic, it is high affinity, it is lyophobic is low affinity. Lyophilic, it is stable. Lyophobic is highly unstable. Lyophilic colloid, they are reversible. Lyophobic uh, lyophobic colloid, they are irreversible. Another one more, let us write. So it is highly solvated. Lyophilic, lyophobic, it is not solvated. So A question is done. 41 question. Now let us come to B question. They are asked is to write the expression of Freundlich Absorption theorem. In this isotherm, what is the value of 1 by n to show the that absorption is independent of pressure? Formula also you should write, and we have to write the expression of Freundlich adsorption theorem. So B question. So its formula is x by m is equal to Kp 1 by n, where 1 by n it is equal to 0. Okay, so here formula we have wrote what is the value we will get 1 by n, it is equal to 0. So 0 is the answer. So here the answer is also got. So 1 mark here formula, and in value is 0. We have wrote that also. So therefore P1 is done. So 41 question is done. So by this your fourth one, that is part D, 5 mark. Here 3 questions we should attend. So we have attended. We have solved all these questions. 5 marks question part D is done. Now part D is fifth main, that is 5 marks question only, but here you should attend any 4. So that let us start. 42A. They have here 3 questions. They have 3 sub questions they have given. That is, we have to explain Schwartz reaction with an example. So with an example, we have to explain Schwartz reaction they have given. So let us write it. Short reaction letter. What is meant by short reaction? Let us write the synthesis of alkyl fluoride alkyl fluorides is best accomplished by heating an alkyl chloride or alkyl chloride or alkyl bromide in the presence of a metallic fluoride, in the presence of a metallic fluoride, like metallic fluoride such as AgF, Hg2F2, COF2, and etc. This reaction is called as Schwartz reaction. Okay, and formula is with an example. There are so H3 CBr plus AgF gives H3 CCl plus AgBr. This is the reaction they have given. So 2 marks you will get, 1 mark for explanation and 1 marks for the example. Now they ask B question, what is Grignard reagents, and write its general formula. Okay, what is Grignard reagents and write its general formula, they are asked. So Grignard reagent, so the organomagnesium halide compound, which are formed by reaction of alkyl halide with Mg in dry ether. They are called as Grignard reagent. Okay, so E is done. Question number B with the general formula also you should have to write. So general formula it will be R mgx. So B question B also we have done. Means sub question B also we have solved. So sub question C. Write the poisonous gas evolved when chloroform is oxidized by air in the presence of light. So the gas is dehydration of. So the gas is. Wait, the gas that we get is carbonic carbonyl carbonyl chloride, or also we can say it as phosgene. That formula is COCl2. This is a gas that is evolved when chloroform is oxidized by air in the presence of light. So question number C, sub question C is also done. So question number 42 is also done. Let us move on to our next question, that is question number 43. Here they are asked to write the 3 steps that are involved in the mechanism of catalyst dehydration of ethanol to ethane. Okay, so let us write that 3 step. 43. Yeah. First one is CH3CH2. Oh, first let us write this one. H plus is here. So it will be CH3 CH2 O plus H. This one is the dehydration of ethanol to ethane first. Then after this, the next one is ethanol to. First, let us write it is ethanol, right? CH3 CH2 O plus H. Okay, here it is very much slow. It is reversible also, so it is very much slow. And CH2 plus CH2 plus H2O, that is protonated alcohol. It is here ethylene alcohol we have taken. Ethyl alcohol. Okay, ethyl alcohol we have taken. Next, so there ethyl alcohol. This one is this. Ethyl alcohol is this one, and this one is the protonated alcohol. This one is the protonated alcohol, and this one, that reaction we have got here is it is ethyl carbonation. Finally, ethyl carbonation. Let us write it. Final reaction H CH2 CH2 plus. Okay, reversible. CH2 double bond CH2 plus H plus. This is the final. So this one is the ethyl alcohol, and this one we got, it is protonated alcohol, and this protonated alcohol again we have reacted, and we have done the reaction, and we got ethyl carbonate. Finally is there this reaction, we finally is the this one. So this is the three-step mechanism of the acid catalyzed dehydration of ethanol to ethane. So if you want, you can write the names. So don't write sometimes names, they may not see. While writing names you may confuse and you may write wrong names, so by that you may lose the marks. So I believe you don't write the names. They see only the reaction how you have written. If reaction is correct, reactions here it is correct, then they will give the mark. So A is done. B question they ask, what is Lucas agents and which class of alcohol does not produce turbidity with it at room temperature? So Lucas agent is a mixture. It is a mixture of concentrated HCl and anhydrous zinc chloride. So this question they may have asked you in the your Viva question also, in your practical exam Viva question also. So from that time you should remember this question. They may ask this question anywhere. So which class of alcohol does not produce turbidity with it at room temperature? So primary alcohol does not produce turbidity with it at room temperature. Okay, so B is also done. So question number 43 is done. So now let us move on to the next question, that is question number 44. Here they are asked, how is phenol manufactured by cumin process? So cumin process we have to write here. First here CH3 single bond CH single bond Q, this is cumin we are writing first. So while writing in the exam, be careful, you should not overmark, like writing this and again you should not write like this, it will become 2. Where it is there you should write only that side, like here it is there and here it is there and here it is there. Okay, it is cumin, and they like this white bit here mistake, don't do here and don't scratch it. If you did mistake, no problem, once you write full here, so that again while doing means once you write all reaction here, then without doing mistake again write here another that same reaction in the next line and scratch this reaction. Okay, so they will give you marks, they will not cut you marks because reaction will be correct. If you do your reaction mistake, they may cut your marks. Okay, and don't mark again. Okay, once you have written, it is done. You should not put line, extend the line, put it, make it dark, don't do like that. And here next we will get is CH3 single bond C single bond O single bond O single bond H, here CH3 It is cumin hydroperoxide. Finally, we'll get H plus H2O. When we react, we'll get OH plus CH 3 COCH3. So this is the cumin process, and then the question B they asked, explain Kolb's reaction with an equation. Question B this they asked, question A we have done. Question B they have asked, explain Kolb's reaction. So B, when Kolb's reaction, when phenol is heated with NaOH, gives sodium phenate, and then CO2 is passed through it and followed by acidification gives salicylic acid. This is the Kolb's reaction. Now with an equation also they asked, so let us write the equation here. Equation of Kolb's reaction. So first OH NaOH ONA first one CO2, second one H plus OH here single bond COOH. So this is the 2, it is salicylic acid, okay, salicylic acid. So question number 44, sub question B is done. So therefore question number 44 is done. Let us move on to our next question, that is question number 45. Here first question we are asked, how does the formaldehyde react with concentrated alkali on heating? And also we have to name this reaction they are asked. Okay. So that reaction also we should write. So let us write H C double bond O, here H plus H C double bond O H plus concentrated KOH gives delta HCH H OH plus H on C double bond O. Okay, this is methanol. It is potassium formulate. It is formaldehyde, and this is known as Kennesaro's reaction. It is said Kennesaro's reaction. So question number A is done. So we have written the formaldehyde reaction with alkali on heating, and this reaction is known as Cannizzaro reaction. That also we have written. Question number B they have given. So here only I will write. It's better. You will understand. So in X place, here only I will write. It's very easy. You will understand. In X place, if it's single bond CH3, here it is if we react it with CrO2 Cl2. Okay, we'll get this reaction. And Y place it is H2O or H plus. Okay, H2O or H plus. So in the X place, let us write here also B1. X is equal to C or O2 Cl2 comma Y is equal to K not H2O H plus. If we react, we'll get CHO here. Here, if we react with Cr2 Cl, Cr1O to Cl2. Okay. So B question is also done. So question number 45 is also done. So now moving on to our next question, that is question number 46. Here they asked what type of carboxylic acid undergoes L. Volhard Zielinski reaction, and we have to explain that reaction with an example they have asked. Okay, so here is the question. I believe you can see the question. So let us see the answer now. For the 46th one A question. So carboxylic acid, it under or it having an alpha hydrogen, carboxylic acid which are having an alpha hydrogen undergo Hell Volhard Zielinski, that is HVZ reaction. So carboxylic acid which are having halogenated alpha position on, and also what is carboxylic acid there? So carboxylic acid having an alpha hydrogen or halogenated at the alpha position of treatment with chlorine or with bromide in the presence of small amount of red phosphorus to give a alcarboxylic acid. It is known as the HZ or Held-Wohlard-Zelinsky process. Reaction. Now we have to also explain this reaction with an example. Let us give like or single bond CH2 single bond COOH. First one X2, that is red phosphorus. Okay, I'm writing in short form red phosphorus. Here second one is H2O. So or CH single bond COH. Here CH is with X. So X Cl2 pure. This is A all carboxylic acid. So A is done. Moving on to our next question, that is A question, sub question A is done. Sub question B, here they have asked among the formic acid and acetic acid which is weaker acid and why, they have asked. So among the formic acid and acetic acid is weaker. Acetic acid is weaker. Acetic acid is weaker. The reason is it is due to instability of carboxylic anion. It is due to instability of carboxylic anion because of EDG effect of CH3 group in acetic acid. So due to the EDG effect of CH3 group in acetic acid is weaker when compared to formic acid. So question number B is done. Question number B is done. 46th question is also done. Moving on to our next question, that is question number 47. Here three sub questions they have asked. Three sub questions they have asked. First one is explain carbylamide reaction with the equation. So aliphatic acid and aliphatic and aromatic primary amines on heating with chloroform and ethanolic potassium hydroxide form isocyanides. This reaction is called as carboylamine reaction. The equation is R single bond NH2 plus CHCl3 plus 3KOH. When it is heated, we'll get R single bond NC plus 3KCl plus 3H2O. So E is done. Question number 47 E is done. Question number 47, moving to the next one, that is B. Here they asked, how is aniline prepared from nitrobenzene? So nitrobenzene is reduced to aniline by, so B1, nitrobenzene is reduced to aniline by passing hydrogen gas in the presence of finely divided nickel, palladium or platinum, and also by reduction with metal in acidic medium. So due to this, aniline is prepared from nitrobenzene. Now NO2 single bond NO2 H2PD ethanol will get. So here I'm doing mistakes. I'm like drawing over the, so don't do like that. NH3 NH2 NH3 and NH2, and after this here second one NO2, so it should be straight line. Okay, don't overdraw. As I said, I am its video, so I am doing like this. You don't overdraw. Sn plus HCl, okay. So question number B is done. We have also written the reaction and how it works we have explained. Now question number C, give the IUPAC name of trimethylene. So the IUPAC name of trimethylene, it is N dimethyl Dimethylmethanamide. C is question C. Sub question C is done. So question number 47 is done. So let us move on to our next question, that is question number 48. So in question number 48, a question they asked, write the Howard structure of maltose. What is so? We have to write the Howard structure of maltose here. And O here also. Okay. After this here H O H CH2OH H here also you should make some gap. OH here OH H O H. It is. Then here O H OH OH H OH here HCH2OH. Okay, so this is the Howard structure of maltose. Then B question that they have asked is, what are polysaccharides, and give an example. What is polysaccharides, and we have to give its example. So polysaccharides or carbohydrates which on hydrolysis yield large number of monosaccharides. Example, starch and glycogen. C. Name any one vitamin that is stored in liver and adipose tissue. So B is done. C is vitamin A, vitamin E, T, and K. Okay. So these in this they have asked only one. So let us write any. You can write any one. So C is done. So therefore question number 48 is done. Now question number 49 they have asked, what are fibrous protein and name the protein present in hair. So proteins having fiber-like structure are called fibrous protein. Protein that is present in hair is keratin. B1 mentioned two hormones which regulate the glucose level in the blood. So the two hormones that regulate glucose level in the blood is insulin, one is, and another is glucogen. Next, 49C question. Write the name of the nitrogen base present only in DNA but not in RNA. So the name of the nitrogen base present in only DNA but not in RNA is diamine. So by this question number 49 is a question A, B and C we have done. So therefore question number 49 is done. Let us move to the last question of this chemistry question paper, 12th standard chemistry question paper 2022 Karnataka board. So it is 15th question. A question they asked, name the two monomers present in nylon 66. The two monomers that are present in nylon 66 is adipic acid. One is adipic acid and another one is hexamethylene diamine. These are the two monomers present in nylon 66. What is vulcanization of rubber, they have asked. The vulcanization of rubber, it is the process of heating natural rubber with sulfur powder at 373 to 450 Kelvin is called vulcanization of rubber. Finally, last question, question C. Write the name of the biodegradable polymer used in the manufacture of orthopedic devices. So the biodegradable polymer that is used to manufacture of orthopedic devices is PHBV is the polymer name. So question number 50, sub question B and C are done. So therefore question 50 is done. So therefore all the questions of this chemistry question paper of 2022 Karnataka board is solved. So therefore I believe that you have understand all the questions how I solved. So okay friends, see you in my next video solving another question or some another question paper or any other explanation video. Till then take care, have a nice day, bye my dear friends.